Hi there, I am teacher Karie. In this video, we are going to learn about inverse functions. This is Module 3 of General Mathematics for grade 11. This lesson is anchored on the content standard where the learner demonstrates understanding of key concepts of inverse functions and on the performance standard where the learner is able to apply the concepts of inverse functions to formulate and solve real-life problems with precision and accuracy. After using this module, you are expected to represent real-life situations using one-to-one functions, determine the inverse of a one-to-one function, represent an inverse function through its table of values and graph, find the domain and range of an inverse function. Lastly, solve problems involving inverse function. This lesson focuses on the essential understanding where the learners will understand that the concepts of one-to-one functions and inverse functions have wide applications in real life and are useful tools to develop critical thinking and problem-solving skills. This lesson also focuses on the essential question, how does the concepts on one-to-one function and inverse function facilitate in finding solutions to real-life problems and develop critical thinking skills? Are you excited? Let's begin. Explore your understanding. You will start with exploratory activities that will present to you the basic concepts of the one-to-one function. Let's begin with activity 1. Determine whether the given is one-to-one function or not. This time you will focus on even numbers, and then later on your own you will try to answer odd numbers. Recall that a function f is one-to-one if no two elements in the domain of f correspond to the same element in the range of f. In other words, x in the domain has exactly one image in the range. Let's begin with number 2, person and citizenship. At first thought, we might think that this is one-to-one, but recall the idea that there is sometimes dual citizenship. That's right. A person can be Filipino and American at the same time, as well as a person can be Filipino and Chinese at the same time. Therefore, number 2 is not one-to-one. Let's go on to number 4. We are given h of x. We are given the function h of x equals x squared plus 2. In the previous lesson in Module 1, we have learned that this is a function. But is it one-to-one? Recall that when you input any x value here, it will produce two sets or two kinds of y, the positive and the negative square root. Then, that's it. We can say that it's not one-to-one. Let's go on to number 6. That's right, it's one-to-one. b of x is equal to 3x minus 4 is linear, and all linear functions are one-to-one. Alright, let's go to number 8. We can see clearly a graph. It is a parabola. So, similar reasons apply to number 4 for number 8. It is not one-to-one. How about number 10? You're right. It clearly is one-to-one. Now that we have discussed the reasons for the answers for the even numbers, can you do the same for the odd number items? Make sure to explain your answers. You can pause this video, watch it again if you want to fully grasp the concept of one-to-one. But if you understood that, let's go on to the next. Firm up your understanding. Now you will step on. Appreciate learning more about the concepts of one-to-one function and inverse function. You will meet interesting activities that will help you. The function f, as we've known in activity 1, is one-to-one if for any x sub 1 or x sub 2 in the domain of f, then f of x sub 1 is not equal to f of x sub 2. That is, the same y value is never paired with two different x values. Let's focus on the horizontal line test. A function is one-to-one if each horizontal line does not intersect the graph at more than one point. Get it right. We can recheck number 8 and number 10 with this test. Let me change my pointer to a pen. If I put, let me change the color. If I put horizontal lines on this graph, we can see that these horizontal lines intersect the graph at more than one point. See, they intersect the graph at about 2 points. So we can be sure that number 8 is really not 1-to-1. It did not pass the horizontal line test. What about number 10? If you try to draw horizontal lines, pardon my not straight horizontal lines, but if they were straight, they would still intersect the graph only once. Therefore, we're sure that number 10 is 1-to-1. Okay, let's go back to the next slide. The vertical and horizontal line test. All functions satisfy the vertical line test. We have discussed that in Module 1. All 1-to-1 functions satisfy both the vertical and horizontal line test. Again, the vertical line test is to check if it's a function, and the horizontal line test is to check if it's 1-to-1. If it passes both, then it is a 1-to-1 function. Why is that important? That is important because if we let A to be a 1-to-1 function with domain A and range B, the inverse of the function f, denoted by f with the -1 raised as an exponent but read as f inverse of something, is a function with domain B and range A. Notice that the domain A becomes the range A in the inverse function, while the range B in the original function becomes the domain B in the inverse function. Defined by f inverse of y is equal to x if and only if f of x is equal to y for any y in B. Again, a function has an inverse if and only if it is 1-to-1. Functions that are not 1-to-1 don't have inverses. So you might want to check that when you try to solve some problems. And if you cannot find an inverse, probably it is not 1-to-1. Steps in finding the inverse of 1-to-1 function. We only have 3 steps. The first 2 steps are very easy. We will be spending more time on the third. But if you can practice on more problems, if you can get the hang of it, then the third one will be easy for you. It's only at the beginning where it's difficult, but eventually when you practice it, in the end, it'll be easier. So first step is to write the function in the form y is equal to f of x. Interchange the x and y variables, and then transform the equation in the form y is equal to terms in x. Let us look closely at example A. The first step is to write the function in the form y is equal to f of x. That is why we have y is equal to 3x plus 1. Interchanging x and y, we have x equals 3y plus 1. Steps 1 and 2 are very easy. Let's go to step 3. Our goal is to solve again for y. I mean, transform the equation into y is equal to with the terms of x here. So what we do is isolate the y on one side and then put the x on the other side. Or basically, we are subtracting minus 3y minus x on this side and then minus 3y minus x on this side as well. We are left with negative 3y equals negative x plus 1. And then multiplying both sides with negative 1/3, we get y is equal to negative x plus 1 over negative 3. Thus, simplifying, we get x minus 1 over 3. Did you get that right? Okay. Therefore, the inverse of the given function is f negative 1, or f inverse of x is equal to x minus 1 over 3. Let's go on to the next. We still have examples B and C. Recall the steps. I've written them here for your reference. Write the function in the form y is equal to f of x, interchange the x and y variables, transform the equation in the form y equals in terms of x. Let's go to letter B. Find the inverse of f of x is equal to 3x plus 1 over 2x minus 1. We have first step, y is equal to 3x plus 1 over 2x minus 1. Second step, we simply exchange y with x and our x with y. We get x is equal to 3y plus 1 over 2y. Now, for the third step, we are taught to simply multiply it on this side, right? But the idea there is to multiply both sides with the least common denominator, which is 2y minus 1. Doing that gives us x times 2y minus 1 equals 3y plus 1. Distributing x, we get 2xy minus x equals 3y plus 1. Then, we try to combine all terms with y. I mean, not combine. Isolate them on one side and all terms with x only, or the constants on the right side. So we get 2xy minus 3y equals x plus 1. Isolating y, we get y times 2x minus 3 equals x plus 1. Leaving us with y equals x plus 1 over 2x minus 3. Therefore, the inverse of the given function is f inverse equals x plus 1 over 2x minus 3. Can you do the same for letter C? I think this is very easy. All right, first step is y equals x cubed minus 2. Second step is x equals y cubed minus 2. The third step is to put again all the y on one side. Negative y cubed equals negative x minus 2. Dividing everything with negative 1 or multiplying everything with negative 1, we get y cubed equals x plus 2. And then getting the cube root, we have y equals cube root of x squared plus 2. Therefore, the inverse of the given function is cube root of x squared plus 2. I hope you got that right, but if it isn't sinking in yet, you can actually pause the video, watch how examples A, B, and C are explained before you go on to the next activity. Activity 2 is where we put into practice what we have just learned. Now, again, similar to activity 1, we will focus on explaining even numbers because later on you will be solving on the odd numbers yourselves. So let's start with number 2. F of x is equal to 2x minus 3 over x plus 4. We are to determine the inverse of the following functions. Again, if you're familiar, this is a rational function. All right, first step, y is equal to 2x minus 3 over x plus 4. Step 2, this becomes x equals 2y minus 3 over y plus 4. Step 3, multiplying both sides with the least common denominator y plus 4, we get x times y plus 4 equals 2y minus 3. Distributing x, we have xy plus 4x equals 2y minus 3. Isolating y on the left side, all terms with y, we have xy minus 2y equals negative 4x minus 3. Isolating y, we have y times x minus 2 equals negative 4x minus 3. And lastly, we have y equals negative 4x minus 3 over x minus 2. This is now our inverse function. Let's go on to number 4. Step 1, y is equal to 4x plus 3. Step 2, x is equal to 4y plus 3. Step 3, negative 4y equals negative x plus 3. I hope you see what I did there. Then dividing everything with negative 4 or multiplying everything with negative 1/4, we get y is equal to x over 4 minus 3 over 4, or simply y is equal to x minus 3 over 4. This is now our inverse function. All right, you may pause the video, you may review, but if you already know how to do it, then you can go over with the odd numbers. Numbers 1 and 3, write your solution and explain in as much as you can. Deepen your understanding. You take more challenging activities about inverse functions through table of values, graph, and solving. The domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. We can see that here clearly. The graph of the inverse function can be obtained by reflecting the graph of the original function about the line y is equal to x. So if we try to draw the line of y is equal to x, that's somewhere here, right? I hope I get this straight. Somewhere here. This is the line y is equal to x. And then if we draw this, we can see that the graph of the inverse is merely, where's the pointer? Is merely a reflection, I hope I get this straight, of the original function. Again, you can do this on a paper where it's very clear. So if we fold along here, we can see that this original function, that the inverse function is merely a reflection of the original function. Okay, so before we go on to example B, let's go on first to example 1. I forgot about example 1. Okay, let's go on to example 1. We have here a set of ordered pairs, knowing that this is a one-to-one function, and then the domain is 1, 2, 3, and 4, and the range is 2, 4, 6, 8. Then the inverse is 2, 1, 4, 2, 6, 3, 8, 4. Notice that we just interchange the x and the y. Now this inverse function has the domain 2, 4, 6, 8, which is the range of the original function, and the range is the domain of the original function. For letter B, I've shown you the graph. Now let's go on to the domain. F of x is equal to 3x minus 2. The domain is the set of all real numbers. So that becomes the range. The range is the set of all real numbers as well, and that becomes the domain. Now look at the values. Negative 3, negative 2, negative 1, 0, 1, 2, 3. You can assign any values for x, solve for y, and then graph. Now in the inverse, the x values becomes the y values, and then the y values become the x values. This will be clearly shown on the next example. Okay, we have example C. Now this is a rational function. Okay, this is a rational function with the domain x, element of real numbers, but x not equal to 3. Note that in a rational function, the x value that is not part of the domain is the value that will make the denominator 0, because when the denominator is 0, the entire term or the entire function becomes undefined. So that's why we have not equal to 3. So in the inverse function, this becomes the domain. Now, for the vertical asymptote, we have x equals 3, since that will make the denominator 0. So we have here x equals 3. We have this one. That becomes the horizontal asymptote of our inverse function y is equal to 3. Now, to get the horizontal asymptote, since they have the same degree of degree 1, we get the ratio of the leading coefficients of the numerator and the denominator. In this case, 1 over 1. So we have the horizontal asymptote y is equal to 1, as shown here. But that becomes the vertical asymptote of our inverse function, as shown here. So the range involves all real numbers except for when the horizontal asymptote, or for the value of the y value of the horizontal asymptote, except for when y is equal to 1. As you can see, that the inverse of this graph is 3x plus 2 equals x minus 1. If you try to draw here again, or if you try to fold, I'm going to use red. If you're going to try to fold this one on the line y is equal to x and draw both graphs in one paper, you will see that this is just a mirror reflection or a mirror image of the original function. Can you do that on paper? Let's see you try to do that on paper. Graph the first function, graph the second function, try to fold it here, y is equal to x, and see that the inverse function that you have created is just merely a reflection or an image of the original function. Okay, if that is clear to you, you are ready for the next activity. Oh, let us have a review. Range and domain. The domain becomes the range. The vertical asymptote becomes the horizontal asymptote. The horizontal asymptote becomes the vertical asymptote here. The x values in the original graph, in the original table of values, becomes the y values in the table of values of the inverse, and vice versa, looking at the graph, right? Go on to the next activity. Now it's time to apply what you have learned about inverse functions in this activity. Pause the video to give you ample time to answer. Activity 4, determine the domain and the range of the inverse of the following function and then sketch the graph of the inverse function. To self-check your solutions, your answers should be this for number 2. You have to get the solution first, try to understand before you will answer number 1 and number 3. If you got that right, you can now proceed to answering the odd number items. Now it's time to apply what you have learned about inverse functions in real-life word problems. You are given here 3 word problems and you're going to solve them. Pause the video again to give you ample time to answer. Self-check your solutions. Your answers should be, or your answer should be 4 for number 2. Why is that? It's up to you to solve. If you got the answer right again, you can now proceed to odd-numbered items. This might be difficult at first, but once you get the hang of solving word problems by applying the concept you just have learned, then it will become easier for you as time goes by. Again, remember, it's only difficult at the start. Transfer your understanding. Here is another activity that will help you apply your learning about concepts of one-to-one functions and inverse functions in real life. You're going to write your third journal by creating a real-life situation where knowledge of one-to-one functions and inverse functions can be applied. One situation for one-to-one and another situation for inverse. You can use this criteria for self-scoring, or if I am your teacher this current semester, I'll be using this criteria for grading your journals. Enjoy! After going through all the activities, what have we learned? We have represented real-life situations using one-to-one functions. We have determined the inverse of a one-to-one function. We have represented an inverse function through its table of values and graph. We found the domain and range of an inverse function. And we solved problems involving inverse function. Congratulations! Achievement unlocked. Remember that if a function is one-to-one and onto, then its inverse function exists. And similarly, when you're simply an honest person, you will find many inverse people in your life. But worry not, because you are ready. Bravo! Don't forget to comment down below, like and subscribe, and stay tuned for more general mathematics videos. Once again, this is Teacher Karie. See you next time. Bye!